Hi, this is Matt Morrison with Technically Speaking at Source Allies. Today, I'm going to be talking about mocking responsibly. This is part 3 of a series, so if you haven't seen parts 1 and 2 yet, check out the links below to get caught up. We're going to pick up right where we left off on part 2. Again, today we're going to be using Python. Haley, if you wouldn't mind adding some more of that sweet, sweet Python flair. Thank you. Today we're going to be talking about what I call agnostic specialized mocking. Agnostic because with this strategy, it doesn't care as much about what specific library you're using, and specialized because unlike general purpose mocking, it really only deals with mocking one type of thing. In this case, it's going to be like web requests. Okay, let's review the code where we left off in part 2. So here are our tests. We have one real test that's not mocking anything at all. And we have our specific test here that's using the responses library to mock the responses or the requests that the request library are making. And we know where we left it last time is we were using URL open, which doesn't work. So if I try to run these tests in the state that they're in right now, it's not going to work. Right. So let's go ahead and switch this back to using requests. I'm just going to comment that out right now and return response.text. Okay. Back to passing. So now we're going to switch over to an agnostic specialized tool. In this case, I'm using a library called VCR. And let's take a look at what we're doing here. So we're using this VCR decorator and saying that we want to use a cassette. I'll get into a little bit more detail on what a cassette is in just a minute. We're setting a couple different parameters here. We're setting a record mode to new episodes. There are a handful of different record modes, which we'll talk more about when we talk about the cassettes. And then we have this match on argument. And we have a very simple application right now. We really just care about the URI and the method. So we know that we're going to be making GET requests to sourceallies.com. We don't care about headers or authentication or anything like that. So we're just going to keep it simple. Then our actual test actually is nearly identical to our real test, which is great, with one exception that I'm going to add here. There. Now they're the same. Same test. The only difference is the decorator. Okay. So let's talk a little bit about what VCR does and what a cassette is. So VCR kind of is this like invisible pass-through where when our application makes a request, VCR is going to intercept that request, save the entirety of the request, but then let the request go ahead and go through. And then when the response comes back, it's going to save the entirety of the response and then give it back to us like nothing happened. Now this is where the record mode comes into play. So I have the record mode set to new episodes. You can also do all or none, and maybe some others. But new episodes is what we're going to use. And what that means is basically any new web requests that happen are going to be recorded, and any existing web requests that happen are going to be replayed. So when I make a web request from my application, when I have VCR turned on, VCR is going to look in the cassettes that have been saved and see if that request already exists. It's going to specifically be matching on the URI and the method. When VCR finds a match and our record mode is set to new episodes, it's going to just give us back what it saved from the last time it stored the response. So it's not going to actually allow that request to go through. It's just going to replay the request that has already been saved. So let's go ahead and run this test. But before we do, actually, let's take a look at our file system. So we have a few things in here, our application.py and our application text, and we have this test mock thing. I'm going to go ahead and delete that. Okay, so test mock is gone. Test mock also happens to be the name of our test. We'll come back to that. Okay, let's run our tests. They all pass, and our test mock is back. So this test mock is actually our cassette. You can do some configuration that would allow you to name it differently, put it in a folder, do different things like that. We don't care about that for now. We're just keeping it simple. So let's go ahead and open this really quick and see what it looks like. So right away, oof, lots of stuff. Let's come down to here. Here's our request. Okay, so here's our GET request. It's a GET request to sourceallies.com with a response of a bunch of HTML. So it looks like a web page. So the interesting thing is I'm going to go ahead and close that and remove it again just to show something here. So we're running our tests, and we see we ran 2 tests in about 1 second. If we run them again, slightly less, not a ton less, but okay, we're about 0.6 seconds. So it is faster. Let's do one more experiment just to kind of see what's happening. I'm going to skip our real test for now. And I'm going to also remove our cassette and then run PyTest. Okay, so we have a pass test in 0.5 seconds and a skip test. Okay, so it's much more consistent, 0.178 seconds for our test to run. And if we delete our test mock again and run it again, you can see it's back up to 0.5, back down to 0.1. So it is clearly cutting out that network call, so we can tell that it's a lot faster. Okay, let's get rid of this again. So now the big benefit to this is, and the thing that differentiates it from responses, is that this is an agnostic tool. So in theory, we can swap back to our URL lib example if we needed to for whatever reason and run our tests, and they still pass. And if I run it a couple times just to kind of see 0.5, 0.4, 0.6, 0.5, 0.3, if I remove that test mock, let's run the test again. Okay, 0.9, so it's a little bit slower. And then we're back down to the 0.5, 0.4. So we could come back and look, and we have, yeah, it's all back again. So the cassette that we recorded using the requests library, we were able to reuse and replay using the URL lib library. And now let's do the opposite. Let's flip it. So we've recorded the most recent cassette with the URL lib, and let's replay it with requests. Just swap out everything back to requests. And yeah, still works. That's great. So that's the agnostic part, where VCR doesn't care as much. There are going to still be some limitations. You're not going to be able to implement your own HTTP library and have VCR just automatically know, unless you happen to be using some of the same underlying tools. But This is super helpful if you're in an environment where you potentially are going to be swapping out tools. Having a testing tool that's agnostic, where your tests can still let you know that your application is properly functioning, can be very advantageous. Let's take a look at one other thing. I want to see what happens when our URL changes. We'll do the same accidental typo here and run our test again. Okay, so we got failed to resolve sourceallies.com, and both our real test and our mock test failed in the exact same way. So that's probably not ideal, depending on what we really want to have happen. Because our record mode is set to new episodes, the VCR library is just seeing this as a request that it hasn't seen before, so it's going to try to make it for real. If we want that not to happen, and we want no new recordings, we only want to replay existing recordings, we can set that to none and run our tests, and we should get a different error. Yes, we do. So we can see VCR gives us some pretty verbose output about not finding any matches on what it was trying to do. And unfortunately, I think because of that last test that I ran, I think actually recorded the bad request with the bad URL. Did it? No, maybe not. Nope, I guess it didn't. Okay, that's fine. Okay, one last thing I want to show you about VCR. Another advantage to using a tool like this, where we essentially have these responses saved off, is, let's say in our hypothetical application, we want to do some kind of experimental change. Let's say this is a JSON API, and we want to add a bunch of fields to it, or change the structure of the JSON and just kind of see how that impacts our application. I can just come in and edit this cassette file. I would not recommend doing this as a permanent way of testing, but as a way of kind of exploring different things. It can be a good tool. So let's look for slippers. Okay, so we've got slippers in here a few times. So I'm going to replace slippers with, oh, did I get that right? Slippers with Crocs. So now we have in our response, Source Allies is a technology services company powered by people in Crocs. Let's see. And I do need to fix the URL that I changed. Put that back. Okay, so we can see that our real test passed, which I would expect because it's really going out to the real website. We didn't just update the real website. All we did was update our cassette. And our mock test failed because it's looking for powered by people in slippers, and we can see here that it says powered by people in Crocs. So that may or may not be a way that you can kind of experiment with some of your tests. So depending on your application, the tools that you're using, your use cases, if you're switching between different libraries frequently, potentially using this agnostic specialized mocking strategy may be helpful for you. If not, you have the specific specialized mocking strategy that you can use, And if that's not appropriate either, you always have the general purpose mocking strategy. And all of those can be used effectively depending on your situation. This has been Matt Morrison with Technically Speaking at Source Allies. Do you have a topic you want to see covered? Comment down below. Check out sourceallies.com to learn more about us. Thanks for watching, and we'll see you next time.